Welcome to Renaissance Charge Videos. I'm Rick Friedrich, and today we're going to look at how to do basic vehicle conversion here. So here we have a Veloster that one of our customers was able to get for us, and we did a project here for multiple reasons. One of them was to give my son some work and experience, and so we created electrical conversion from gasoline to basically make this into a golf cart. So I'm going to go over some of the details here, and I'm going to say that we are selling this car right now. For those who are very serious, you can contact me in the description. There'll be an email link there. So we're down in the very far south here in Florida right now, and we will be selling this, well, anywhere if somebody's interested in it. Well, let's go over some of the things that we had to do in this car. So this is a rather small car to be able to put lead acid batteries in, and what we did years ago was do two different cars just like this. So we had a Honda that we had done, Honda Civic, initially back in Coeur d'Alene, Idaho, and we never showed that, but we just made real basic conversion where we take the engine out. We'll talk about that in a minute. And literally I had no back seat and just the batteries in the back seat. We drove around that. And what I was doing that for was to get some experience with my customers who have electric vehicles like this, and where they bought our charger. So I always want to identify with my customers. So we made that, and then I actually used that to test out the boat, the big 26-foot boat, and put that motor in there, and to do a comparison to see how much energy it really took electrically to move that boat before we put our motor in, which was remarkable. The big window motor that we had in there was taking a fraction of the energy, plus we were recovering all the energy in the second battery bank, and we ran that boat for 3 years without having to charge up the batteries, just by rotating them around. Of course, that was only in the summer months. So we did a second car, which was the Porsche, and we did it just like this. We made it with a forklift motor. Both of these, all three of these cars then have had a forklift motor in there. You can see down here. It's hard to see, it's outside here. So we take out so let's start from the beginning. What did we do? In the Porsche, first of all, we ended up taking out the conventional motor and putting in one of our motors in at the very end. So then what you do first of all is what we call de-icing it. So this is where you take away all the parts that are gas related. The engine, not the transmission. We usually want to keep the standard transmission, manual transmission, because it's easier to do a conversion, and we'll talk about that in a minute. So we take away the gas motor, the exhaust, the whole exhaust system, the gas tank, the radiator, or as you say in America, radiator. So you would take that out of the front here. You don't need any of that. Now you may have a water cooler for your controller. So this one is the old Curtis controller. We had that in both of those other cars at times. We had a net gain controller until that went on me. We went back to the Curtis controller. So this was a test. Well, let me finish what we have to do, and then we'll talk about why we did it and all that in a minute. So you have all the electronics still working. In this case, we're going to be running it off, or we've been running this for a while, off the regular accessory battery. And then we can have, in this case, we also have a DC converter that takes the power from the main big battery bank and keeps this not only at, charged, but it actually has it as if it's an alternator at like 13.5 volts or something like that. So that is not on here right now. I don't really need it, but we do have a controller with this car. So anyway, this was just an attempt to put the Curtis controller into some air cooling into it so that it doesn't heat up too much and we can drive it normally. So what you end up having to do, the most difficult part of this, it's not really building the battery cage. That's not too difficult, but you do want to do that correctly. But the main part is connecting the forklift motor up to a plate to connect into the transmission, or the transaxle. In this case, it's front wheel drive. So what happens is this still has manual gears that are switched, but there's no clutch plate in there. So you basically drive it as if you had a clutch in there, except you don't have to push down the pedal. And you just have to switch gears when the engine's not revving. So it's not really much different than running with a clutch. But you can't switch gears when the motor is spinning. So anyway, you have to mate the motor exactly to a plate, exactly lined up, and you have usually some kind of spline on the transmission input that you have to mate to, and you have to do that just right. So this one was done by an expert welder in Indiana, customer friend of mine, and my son was able to do this whole project, at least in the beginning phases, pull the engine out and learn some various things that I wanted to teach him, and that's why we did that. We were also we were doing some experiments with this car on a free energy level that are not installed on it right now. So anyway, so what else do you have to do? Really, you have to create the same conditions in order to run the car normally. So for example, we have a air compressor pump here that will come on to do the brake boost, and then that will just come on periodically. It isn't very loud, but that makes it so that you can drive normally. Then it also has electronic power steering. In this case, it is not installed. It comes with this car, that's why we chose it, but we had never had time to connect that up. So I'm driving this now for about, I don't know, 4, 5, 6 months now, just occasionally, and we're doing, without the power steering, it's rather difficult to turn in parking lots when you're starting up. Once you're driving, you don't really notice any difference, but that can be done, set up later on. What we have here is actually a disconnect, a power disconnect, which we were always doing There's two of these, one to shut off the big battery bank and one I have here, because I find these newer cars, they all have too many things running, draining the battery down when you don't need it. So that doesn't necessarily need to be turned off, it's just an option. So again, you have the controller aspect. This is adjusting the power level, and this is not all finalized here. This is just something we've been running preliminary, and we've got some wires running here. This is just to do this relay. I put that in the other day. Of course, that has to be wired through the firewall. So you have the controller, you've got the DC, which would be normally right here, DC converter to keep that charged up. But we find that our batteries are able to run all the loads in here fine for the distances we go, because we don't have any cold temperatures here. And right now there's no air conditioning in this system, but even I drive this all the time, even in 100-degree temperatures, and I'm not really that bad with it. Of course, with our other car, we've got air conditioning. My son likes to have his air conditioning. So that's the only thing that we don't have, is the air conditioning or the power steering hooked up on this. So we end up balancing out the batteries, putting some in the front, some in the back, and we're going to put two more right here, which are in the cab right now. They can go in the back. And so we have several down in the front here, and then so we've got 8 altogether in the front, and we could add some more here if we need to. So this controller is capable of going up to 144 volts of battery bank, and right now it's at 120 volts. So this can get up to 70 miles an hour easily with this voltage, but if we added 2 more batteries, it would be probably just exactly like original power levels. So what else do you have to do? A couple of things here and there, but the speedometer works like normally. All the internal work, all the electronics work. And like I said, the biggest thing is making sure first of all, that the motor is hooked up to the transmission, the transaxle, properly. And then you want to just make sure that you have this properly welded. This is kind of a mixture between welded and bolted in. There's a couple of places that we literally welded it in, which would be easy to break the weld if we needed to change something. So it's not terribly hard to do that, but you want to do it right. And what you notice here is you need to have the motor hooked up so it can flex. You don't want to mount that, just like the transmission and the motor is normally connected through the motor mount right there. So there's a bunch of other things you can learn on some of those electric vehicle conversion forums and website. It's not so big thing as it was when we started out doing this almost 20 years ago. Like, it was very hard to find the Curtis controller. And now they're doing more AC motors and all that. But anyway, this is like a golf cart. It just can go on the highway and drive normal. And there we have it. So if anybody's interested, only serious inquiries. We are selling this now, and let me know. So thanks for watching. So here we are going to take it out for a drive. You can see there's a couple of gauges here that we just need to put resistors on, and then so we can bypass them because they're not working anymore. We've got a amp meter, voltmeter here. So about that, when we have we've been able to increase the capacity of these batteries significantly in a short period of time. I'm only charging this at a 10 amp hour rate, or a 10 amp rate of charge. So what happens is that the battery capacity increases over time with our charger. It doesn't decrease with cycling. Ends up sitting at eventually on a 12 volt section of the batteries about 13.3 with a flooded lead acid battery. You don't see that anywhere else. So we have, to start with, higher capacity. We could drive this car 15% before 15% of its charge before it reaches the conventional voltage charge level once we've fully maxed out that capacity gain in the batteries. But not only that, the big thing with this is that we can actually take this down very low. So it's got lower discharge capacity. So that means that we don't just, when we get to that 10.5 volt voltage on the 12 volt side of things, we don't just drop off and go to zero like everybody else does with these electric cars. When we were out west, people in the electric vehicle club were able to, they were having to tow their cars home when they went too far and they couldn't just get back. Whereas I have a linear discharge on these batteries and it will go down to zero as long as my controller, in this case this controller can go down to 60 some volts before it cuts out. So we can take these batteries a lot deeper. It's kind of like the Joule Thief, except we have real capacity at a lower level than other batteries would just because of our charger. So we're going to run this now on the street. I mean, this is licensed. This is not merely an experimental car. It's fully functional. It's just like I said, the power steering is not on. Once you start moving though, it's not a big deal. So we're going to see kind of some of the amperage here. Of course I'm going to have to shift. So you can see I can push first gear. It won't let me to go full amps, but the as I get up in voltage or in gears, that gives me more. Of course, I can't go faster on the street here because it doesn't allow me to. Speed limit, I mean. So you can see there's a voltage drop under load. That doesn't mean the battery's discharged, it just means there's a voltage drop. So if I let go, you can see the voltage bounce back. In fact, when we stop, the battery can not only regain its voltage, but to some degree, I mean minus its discharge, of course, but it also can, if it's still been recently charged, start to be in a charged mode and still charge up a little tiny bit more than normal. So anyway, this is just driving it. We can gone up to about 80 miles an hour where it's legal. So anyway, I just thought I'd take you guys for a ride and tell you any more details here that I didn't think of. But yeah, this functions pretty much the same. It just doesn't have the air conditioning. Of course, I got the windows open and the sunroof. You know, there we go. So it's fine. So thanks for watching. Hope you enjoyed the ride. One more thing, guys. I forgot to mention that we had really good meetings in Europe. In fact, the last one in not Hamburg, that's where we used to have meetings. Frankfurt was probably the best meeting ever. And I think in all three of the meetings we had mostly electrical engineers there, up to I think 3/4 of the people in one meeting I think were. And so that was quite an interesting experience when we have that many electrical engineers. And I'm not sure if we had any physicists, but we had one scientist who was a guest speaker in Switzerland. And that was really a special moment, I guess. So I really appreciate all the hosts helping out at those meetings, and we're looking to have, we're planning a meeting right now in Lansing again, the same location, exactly 2 months, the 27th, 28th of October. So you can see that on the website. So anyways, thank you all for coming that came to the meetings before and last month. And we just had a great time. So I don't know when we'll see you all again, but we'll keep in touch maybe.